Welcome to the video on LiveScripts example in MATLAB. Let's open the MATLAB by clicking its icon. So you all know this is a default layout of MATLAB. Now since we are creating a new LiveScript, let's go to Home tab and click on New LiveScript. You observe that a live editor is being opened here, and this live editor is now docked into the desktop layout. That means it has now become a part of this desktop layout. So I can maximize this live editor, or I can show that in the form of a docked layout like this. So let me maximize it so that it is visible to you. So this is an example program where I am going to plot the unit impulse function using these LiveScripts. So here you can see a gray shade where the control here is now on the code. So I'm going to start with the title of the program. So let me go to the text mode by clicking here. Now the gray has been vanished. So let me give the title plotting unit impulse function. So since it is a title, I will keep it bold. Then let me type the objective of the program to write the MATLAB code to generate unit impulse signal. So let me unbold this so that it looks nice. So software requirements I am going to write here. A PC or laptop with MATLAB R2020A. Let me insert that some theory here representing the definition of the unit impulse function. So the unit impulse function is defined as mathematically as. So here I am going to insert the equation. Before that I am making all these headings as bold. So going to the insert menu here, and here I am going to insert an equation. So when I click on this, you observe there is a provision for inserting the equation. So I am now giving the mathematical equation of the impulse function. So delta of t equal to 0 when t is equal to 0, and next it is done. Now I want to insert one more equation, that is integral minus infinity. You can observe that I am inserting the equation here in the LiveScript. So minus infinity to infinity delta of t dt is equal to 1, indicating that the area under the unit impulse is equal to 1. So once I have inserted this theory, a small theory, let's go for the discrete version of the unit impulse. So the unit impulse sequence is defined mathematically as. So let me insert one more equation. So delta of n, now I am talking about discrete, so n is a variable, delta of n equal to, and here I am going to represent two definitions here. So representation here as 1 for n equal to 0 and equal to 0 for n, and not equal to symbol can be obtained here. You can see, yeah. So this is a mathematical definition of the unit impulse or unit sequence functions in continuous and discrete domains. Let me insert an image. So going into the insert menu, click on this image. I have an image ready for the unit impulse sequence, so I am selecting it and open. You observe that the image has been inserted. So let me resize it so that it is okay with my font size. Okay, resizing is done. Now this is all I am talking about adding the text. You can see here adding the text. See, you can see here adding the equations. You can see here adding the image. You can see here now. So since I want to see this as a document at the last, so I am giving some formatting. Now after this image I want to insert a section break so that there is no disturbance with my program. So let me write the title program. Let me bold it. And now here I need to insert the code for the sequence. So live editor, I am clicking on this code. Now you can see here the gray option has been opened here where you can type your code. So let me define a variable x equal to zeros. So all functions are with small alphabet, so zeros of 1, 5, ones of 1 and zeros of 1, 5. So zeros function is going to create a set of zeros with a size of 1 by 5, that is a matrix of size 1 by 5. Ones is a command which is going to create a matrix here of size 1 by 1. So like this I have created a vector of x. Now let me create a time variable, that is sequence n, because I am going to plot the discrete unit impulse. Then I am going to plot it now. So using the command stem for the discrete sequence, and now giving some labels. As you all know that x label and y label are being used for giving the labels for the program, for the output or at the end, and giving y label, I can write it as now x of n, yeah, got it, and giving some title. I'm giving the same title as unit impulse sequence. Yeah, it's done. Now giving some grid option also. Yeah, now you can see I have added the program also. So now here I can enter a section break now. So I will have a section break now. So section break is going to divide or show differently the program part or the theory part what you have mentioned. Now here I am going to write the result, that the unit impulse sequence has been plotted. Okay, yeah. So see here, this whatever I have typed here, it is been showing in the as a code here, because it is been pasted in a gray strip. So I want to convert all this into a text. So clicking on this again, text. Yeah, now it has become text. So result is being kept in bold. So it's over. I want to add again one more section break. Yeah, so this is all about now you can see without any execution of the code, you can see this set of code is automatically executed, and you can see the plot of the unit impulse sequence just beside the code. Now you can see here like this. So this is what the importance of the live scripts in MATLAB. So it is very easy to work with live scripts. Now once the code is complete, execution is complete, and you can see the output here. Now let me export this into a document. So here, going to the save function or save command, export to PDF. So I want to give the same name like unit impulse sequence, and I am storing on the desktop. Yes, save, and you can observe the process is going on here. That is, it is all the data whatever you have entered in the live script is been exported to a PDF file. Now you can see a PDF file has been opened. You can see the same order what you have entered in the live script. Now the title, the objective, software requirements, theory, and this is how generally we can prepare a manual also. Now, so this option of exporting to PDF is very useful for the students to take this directly as a printout and record it. No need to write it again and again. You can see the output just below the program and result. So this is ready, the document is ready. You can go for print and record it. That's all. So one more point I want to mention here is there is no rule that all the code lines are being written as a strip like this, what I have shown here. You can insert some text in between. For suppose I want to add a text like this is a this is a code for defining the impulse sequence. So if this is being written in a gray strip, that means it should be a code. That means I need to keep a percentage to make it as a comment. Or for suppose if I don't want to make it as a comment here within the strip, then I'll make it as a text by clicking here. That is text. Now that's all. So this is how you can have the text in between. Now it is nothing to do with the code. Now I can also insert here the text like defining the time interval. Yeah, again I will select it, make it as a text. You can see the code is being split. Yeah, and next the set of lines here what I have shown here is representing the plotting of the impulse sequence. So I will write here again, clicking on the text. Yeah, good. So this code refers to plotting the impulse sequence. Yeah. Next I can insert one more text here like labeling the plot obtained. So these are all like this. So this is an option what we have with the live scripts, and very useful in programming the basic simulation lab. And once again I am trying to export that to a PDF file. So giving some other name like unit impulse. Yeah, that's all. Save it, and you can observe the process. It is exporting to PDF, and now the PDF is been opened. And the same you can see like this. You can see the text, you can see the program lines, you can see the output at the end of the program and the result. So these live scripts are very useful for us to work in labs. No need to write any record again and again. Just export that into PDF and take a print and record it. That's all. This is the end of the video working with an example in live scripts in MATLAB. Thank you.